Hello, everyone, and welcome to our Carbonethic YouTube channel. Martin here for another different video today where we're going to talk about our forest operations with no one else than our Vice President Forest Operation, Mr. Brendan Flanagan. Hello, Brendan. How are you?
Fine, thank you, Martin. How are you?
I'm good. I'm good. So I've heard that you're located in one of the most beautiful forests we have in British Columbia, right?
Absolutely, yeah. So I'm this morning. I'm joining you from Nanaimo on Vancouver Island and coastal Western Hemlock, coastal Douglas fir forests, high productivity, temperate rainforests, and a thriving industry. It's a great place to be based out of.
Yeah. What would you say regarding the average of tree ages? Like, what's the age of?
Well, that's actually really difficult to say. I think southeastern Vancouver Island is overcut, meaning that the forested landowners have reduced the average age of a stand. Um, Temperate rainforests host tons of variety in the age classes, but it's not uncommon to find 800 to a couple, 1,000-year-old trees.
Wow.
But it's like I say, it's such that the second growth forest that exists now is being targeted for harvesting here as well. So the actual age class on Vancouver Island has been reduced compared to what it would historically have been.
Yeah, makes sense. Tell us a little bit about yourself before we talk about our milestones and what we've done and where we're going. So, where are you coming from and why are you in BC?
Well, yeah, okay. So I started my forestry career on at the east coast of Canada in New Brunswick, working for a large private land firm there. I've moved out to British Columbia to pursue forestry and mountain biking, and just enjoy the nature that the province has to offer. And I'm joining Carbonethic because I've got an extensive history in a pretty varied number of roles in the provincial forest sector. And so we've really come to a milestone here recently by conducting our forest inventory. And this is something that I had a pretty heavy hand in tinkering and tailoring with to make sure that it was suitable for our purposes, and then also operationally to orchestrate it so that we can get everybody in and out of the forest safely and harvest data that is useful.
And we're, from what I've heard, we're pushing actually the boundaries regarding the technology that we are using, the processes, because the goal always been to bring transparency and integrity into the forest analysis. And we'll talk about it in a few minutes. But one of the thing I want to cover today was how surprised we were and not on such ways to see that what we had as archives and history regarding the forest was so different from what we've seen while you're boots on the ground. You're there to realize that you get a different perspective of what the forest is compared to what we had as documentation. And that's a big thing, right? That's a big thing.
Yeah, it's the total validity of the project. And so what's problematic is that a lot of landscape planning decisions are made from satellite data that's not exactly specific or tracked as far as whether it's correct or any of these things. And so it's a challenge that we use to our advantage in identifying where and what we should go to begin looking. But of course, once we've identified our area, we need to break it down into more granular forest management exercises. So understanding that the ecosystems vary within one region quite substantially when you're actually boots on the ground compared to that satellite data. And what's really kind of jaw-dropping is that a lot of the focus on that satellite data, its correctness and its use is more in around the coastal setting. And so there's a lot more eyes on the prize in this region. And so you have a potential for a huge variety of changes to come when you actually are boots on the ground. And we did find that, some things were similar for sure, but there were species that the satellite didn't pick up on that. Of course, we did while we're on site. And then, of course, just the actual structure of the forests and how things are growing, and what sort of state that they're in. It's a static inventory that we perform, so it's a glimpse in the timeline, and so being there, boots on the ground, it's really the number one priority for submitting these projects.
So just to give a little quick wrap up of what has been done, if I may, first, if there's some viewers which are joining us for the first time and they don't know what we're talking about. So we secured actually a partnership with the indigenous communities of Cascadenes up north, British Columbia. And this project is at 3.9 million hectares. So it's a massive forest, big as Switzerland as a country, to give you a bit of a perspective. And last year, with actually the financial support of our investors, plus a great partner called Invert World, they gave us the opportunity actually to develop our project, a pilot project, SIA, which is an area up north BC by the border of Yukon. And the first project was a 47,000 hectares of forest to be analyzed. So that gives us, Brendan, the leverage to really start the operation back in 2023 last year to do sampling, forest inventory, and collect the data while in the winter, so we can deliver actually and prepare our next forest carbon offset delivery happening in 2024. So I want to put some pictures on the screen here, Brendan, for you to comment and talk about a little bit of the process. So first, as your responsibility as a VP forest manager is that you talked about it, safety is one of the concern. Second, I assume that when you're talking about 47,000 hectares, you have to identify areas where you can land the team, and you have to use helicopters. Basically, you have no other options because there's no roads in there, correct?
Yeah, that's right. So we're really looking at working inside the Indigenous Protected Conservation Area. And so it in and to itself is untapped. It's been undamaged and left alone. Our partners, their intentions are to leave nothing as nothing. So obviously access and egress are extremely important to getting crews in and out, not just safely, of course, but productively. And it is a challenge across a large land base to keep groups of people within about 10 minutes surface travel to a helicopter pad. We didn't want to go in with a heavy foot and manufacture large helicopter pads or big staging areas or leave a big human trace. And so I've got a pretty large background in helicopter logging projects, and so I employed some of those techniques for sort of a reduced impact, all the while giving us all the access to the topography that we're most interested in, the timber harvest land base specifically. And here you have Kyle and I out at a plot center. So the plots landed where they landed. We don't cherry pick where they go. Some forest types are extremely productive. Others are, sort of a hodgepodge of growing conditions. For example, in this stand, it looks like there's some pretty common birch and some spruce, but nothing's really substantial or merchantable at this point. Nevertheless, those plots are all collected. All the data is collected, categorized, all in the exact same manner as if it were a large spruce balsam stand or a pine stand that we're targeting for harvest next year. And it's all a systematic process. So we had a large crew out there. My directive that we're everyone did a really great job of replicating the plot process across the large land base.
So the way it works, like roughly for people to understand, is you identify a plot, you go there physically, you plant actually a stick, as you can see actually on the left of Kyle, and from there actually you start identifying the highest tree with the species, age class, all of these things are quantified. And from there, in a specific radius, you have to quantify everything of what you see, including, level. So give us a little bit of explanation on the process, Brendan.
Sure. So it's what's really notable is that the survey that we're doing here isn't something that's common practice to the forest industry yet. We're looking at it from a carbon stocking lens, growing conditions affecting those carbon stockings, but it's not a survey for merchantable timber for a submission to the province for logging. And so, yeah, you nailed it there. Just to the right, on the right side of this photo, you can see the two ribbons on a plot stake. And so that is actually where that goes into the forest floor. That is our plot center. These were known coordinates that were navigated to, and then from there, a plot radius is spun. I mentioned earlier, everybody did a great job of using the systematic process. And so we keep it so that it's very systematic in such a way that you reduce human error. So we get to the plot, face true north, find our first tree, and label it number 1, and then work in a clockwise direction. I think you had also mentioned, Martin, the necessity to differentiate between age classes and diameter classes, and ultimately the dominance and structure of the forest. And so we did just that. We've collected data on our largest trees. Those, of course, hold the most weight as far as what carbon stocking is at the spin up of the model run. So meaning that what is actually there right now. And then how is that going to look in the future? Those largest trees have a ton of sway over the growth and yield characteristics of the site. But it's also been very important for us to identify the various carbon pools that exist outside of just those largest, most dominant, most obvious trees. Mm-hmm. One thing became very clear to me when I had spent maybe the first half hour on site is that this forest type is aged. It is old, and as such, the forest is almost folded in on itself as it's worked through succession. So trees grow and die and grow and die in this sort of dynamic flux over time. And in the process of deterioration of that tree, coarse woody debris falls in the ground. Some of that can be merchantable, meaning it could get logged, and others it's just part of a carbon pool. And so we really want to be able to quantify what is in a state of blowdown, and even more specifically, has that blowdown sheared off or has the whole root mat lifted? That might be important for us when we look at the level of rot that we apply to those trees. If a tree shattered itself, it would assumingly already have quite a bit of rot. It's also got a larger surface area. It's also definitely sitting flat on the ground. So we're gonna decay that tree just a little bit faster. Whereas if it's got its root mat lifted up, it could still probably have green limbs on it if it's more recent. And so we just want to apply different characteristics to these various carbon pools. The other thing that was interesting about how we went about this is that we have made it very clear from the start that we want to use remote sensing technologies essentially to support and bolster the field data. Of course, we would love to be able to measure every single tree on a 47,000 hectare plot, but I would be, I'd spend the rest of my career and I would never get to wrap a tape around all of them. And so the remote sensing technologies can be applied to scale up our forest inventory data. And one of the best ways to do that is through what you've got on the screen here. This is essentially the silhouette classes. So the coniferous trees at the tops, we have them class 1 through 9, our deciduous trees on the bottom, D1 through 6. And these can be related to what we see from the optics or the remote sensing outputs to better view what is real, what we know what is actual at the plot. And then instead of trying to guess and infer, okay, it looks like this tree might have a snap top, we can actually go to the card and say, okay, well, it's a D2, it's an aspen class 2. And so we would expect there to be a broken top, it just based off this silhouette alone. It's more of a qualitative measure than a quantitative measure, specifically here. But we think that this, amongst many other tricks up our sleeve, are going to be ways of really welding the real world to the digital world, quite effectively.
And bring transparency and integrity, like with no questions asked. I mean, the people can look actually at the data and look at a sample, and they will see exactly what is the content, which we went actually like 10 times deeper than most other project would. And of course it's costly, but it needs to be done, right? It's heavy lifting of, information and massive data. I mean, I can't imagine the amount of storage required
We're
to
swimming
be
in
able.
it.
Huh?
We're swimming in it for sure.
Yeah, that's heavy lifting.
It's
Heavy lifting stuff.
it's been a talking point a few times, in that one of the co-benefits of the project is just actually increasing scientific knowledge in the region. We're not trying to bring anything other than some insight into what is actually there by spending time to collect and capture and process that data. But it is a formidable exercise, and I think we've done a great job on our first deployment of the investors' capital. It's like you say, it's a massive milestone to deliver the inventory. We had done our original modeling off of this area of interest, and we'd used all of the satellite data that we could, and gave it our best shot. From where we were to where we are now, I reckon there's about an 18 or 17 times improvement just in the sheer number of growth and yield curves that we've created. Again, the growth and yield curves affect the model run significantly. And there's nothing incorrect about that. That in itself is just how the model will work. And so the more growth and yield curves that we create that are known, they're produced from on-site factual trees, the more accurate our modeling is going to be. And so we are looking for transparency. We're not trying to push it towards merchantability or push it towards any one characteristic. I have a background in multi-phase timber development projects, and then in that world, there's some gray area. You can take some good with some bad, and that can do some things for you. Or, there's trees along the edge. But what we're really trying to do is just show a clear picture of what these ecotypes look like. And then hopefully we can start to find these ecotypes throughout the land base at large, and then apply what our known values are to those systems across the larger area.
It's funny, your cat actually just dropped something behind you. I don't know what it is. They're hilarious.
They're a full-time job.
There you go, no doubt. So that said, so while the business development department actually is working, to secure other piece of lands, especially in Canada, and we are also looking in Europe right now. And we are working on other millions of hectares of forest that we want to secure and deliver actually carbon offset models out of. So you collected that heavy work. We got that. We sent actually the forest inventory to be analyzed by third party to confirm that we are right about the information that we got. What's the plan for your team as forest operations for 2024, knowing that we're going to have another tranche of offsets to deliver by 2025? So we finished an inventory on 47,000 hectares. We still have the leftover of 3.9 million hectares to cover. So what's the operation is looking at, regarding your side of the business for 2024, Brendan?
Well, that's a great point. We did, after the fact, say, you know what, let's have somebody else look at this as well. So we did have a third-party forester come through and look at not just how the procedures were conducted and the efficacy of what occurred out there, but just the validity in how we stratified the forest. So we took this one area and we tried to make it more concise to specific garden types. And so it was awesome to have that kind of check mark completed, and we fully expect to carry on with that sort of being a continued effort, third-party verification as we do future sampling. As far as the near term, we want to continue to work on processing a superior model run, so that the things that make up the carbon credit itself are factual as best possible. And we don't think we're at the finish line. I think we're doing great work, but certainly the correct answer, the absolute truth, is still a little bit away from us. And so continue to support our model runs. And then, we'd like to convert our temporary sample plots into permanent sample plots. And so the temporary sample plot program is to create a static inventory to get those initial volumes and growth and yield curves to run the model, and to validate what is in part or inside the forest that is being protected. But then after the fact, we have to monitor and push our scientific knowledge even further. So I suspect that we're going to convert the plots that have been done for the most part into permanent sample plots. And from there, we'll get carbon densities. We'll do a more in-depth analysis of the structure, including coarse woody debris sampling and just the various carbon pools, and get permanent sample plots done so that we can revisit them more frequently and start to imply change monitoring. And other than that, we want to open up new areas, and that can look a few different ways. I think targeting the ecotype, so making sure that we become experts at identifying site series and variants inside of this biogeoclimatic region, and being able to do that with remote sensing, target those areas, and then go put a bunch more temporary sample plots in. I think that's really our goal.
Sweet. Brendan, thanks again for everything of what you've been caught into heavy lifting in the last few months. And I know, like most of the most critical job to be done was to deliver actually the forest inventory, which you've been successful at. So thanks for that. Our investors appreciate it. The operators do. And it's just the beginning of an amazing adventure, because 2024 is going to be another, just bigger scale of what has been done in 2023. Again, thanks again to our financial partners like Invert World and our initial investors who believed in what we were doing, 3.5 years ago. Time flies, man. We've put so much effort to be where we're at, and it's just the beginning of it, right? So, Brendan, thanks again for the info and the explanation today. I think it gives a bit of clarity on what we are trying to accomplish. We're going to keep on having such videos being created every week, trying to give you all the details about how we operate and the purpose of. So thanks again. Have a good weekend. Enjoy actually your mountain biking summer as much as I will. And probably we'll meet again, for a ride somewhere on the island in the next few weeks.
Yeah, I look forward to it. And just to echo what you said, Martin, thank you to everybody involved who has supported the project from then until now. And we look forward to providing good product to everybody.
Thanks. See you guys on our next video. Bye-bye.